Okay, we want to continue section 3.3, video part 3. And before I do that, what I would like to do is just review back over the things we've done so far in chapter 3 since we started this chapter. First thing you need to be able to do, of course, you need to be able to do synthetic division. That was in 3.2. Then we moved to section 3.3. And the first problem that we looked at in 3.3 read something like this. Use the remainder theorem to find f of k. And then it would give you a k value, like 3. So use the remainder theorem to find f of 3. Now I told you at that time, I said there's two ways to do this, but I wanted you to do it by synthetic division. So one of the ways to find, like if I was looking for f of 3, and I was given a function, all I do is, I don't want to plug this number in. That's one way to do it. But the way I wanted you to do it was to do synthetic division on this polynomial. The number that goes out front is the number 3. Whatever's in this parentheses, that's your k value. So put 3 in front, and this goes under the division bar, and go through synthetic division. Whatever your remainder is what f of 3 is equal to. So like if your remainder is negative 17, you put negative 17 right there. And remember I told you whenever you go through synthetic division, your remainder is your y value. The number that's in front of the synthetic division bar is your x value. So if this was negative 17, this would be the ordered pair 3, negative 17. You don't have to write it as an ordered pair, but that's what that is. Okay, then the next thing that we looked at was, in section 3.3 is a question something like this. Determine if k is a 0. And it would give me a k value. And the question is it a 0? How do we do that? Once again, you do synthetic division. I just made this polynomial up. So these numbers go under your synthetic division bar. This number goes out front. And you do synthetic division. If you get a remainder of 0, then the answer to that question is yes. Because f of negative 3 would be equal to 0. But if the remainder is anything else other than 0, then the answer to this would be no. All right, then we looked at another question. And the question said this. Is x minus 4 a factor of this? So in other words, if you could factor this third degree polynomial that has 3 zeros, that has 3 linear factors, would this be one of the 3? Well, I can't factor this. So what we said do is this. X minus 4 is a factor if positive 4 is a 0. So what you do is you do synthetic division on this polynomial with the number 4. If your remainder is 0, then that means that x minus 4 is one of your factors. All right. Then the next problem we looked at, and this is what we looked at right at the end of the last lecture. It says we were given a problem where we were given a third degree polynomial, which means it has 3 zeros, which means it has 3 linear factors. And we were asked to find the 3 zeros, or the 3 linear factors. Remember, whenever you find zeros, you're also finding factors. Whenever you're finding factors, you're also finding zeros. You find those at the same time. So, how do we find the remaining factors or the remaining zeros? Remember, what we do is this. We take the 1 0 that we're given. So like in this problem, we're given that k equal 2 is a 0. That means if you do synthetic division on it, you get a remainder of 0. So you do synthetic division on this problem with that number. You should get a remainder of 0 since you're told that it's a 0. And we did one like this. But after you do synthetic division with this number and you get a remainder of 0, how do you find the remaining two factors or the remaining two zeros? What you do is this. You take your answer, whatever your answer is, that's a second degree polynomial. And you factor that second degree polynomial that's your answer. When you factor that, that will give you your other two factors. So you would have those two, and then if 2 is a 0, x minus 2 is your other factor. So that would give you your three factors. Then the way you find your remaining zeros is by setting those three factors equal to 0. So that's where we've left off. All right, now here's what we want to do. I'm about to give you a problem where I give you a third degree polynomial. And we're going to find the zeros and find the factors. You say, well, Mr. Brandon, we just did that. Yes, but here's the difference. The difference is I'm not going to give you the first 0. See, in any third degree polynomial, if I give you one of the zeros, you can always find the last two. Always. How? Because you do synthetic division with that, get a remainder of 0, and then you solve the quadratic equation that's left to get your other two zeros. So if you can find the first 0 to any third degree polynomial, you can always find the last two. But here's the problem, finding the first one. Now, in the last couple of examples that we worked together, I gave you one of the zeros. So here's what we're about to do now. We're about to learn how to find the zeros to a third degree polynomial when the first one is not given. So you say, all right, Mr. Ryan, I think I know where we're going to go with this. So if you give me a third degree polynomial, let me just make up something here. So if I give you a third degree polynomial, and I want to find the zeros, I'm going to find the three zeros. Or I could say find the linear factors. You say, okay, I know what we're going to have to do. We're going to have to do synthetic division. That's right. On this polynomial. That's correct. And we're going to keep doing this until we get a remainder of 0. That is exactly right. We're going to do synthetic division until we find one that gives us a remainder of 0. Then what will we do? We will take our answer and factor it, and that will give us our other two factors. Here's where the issue is. What number do I try? Do I try 1, 2, 3, 4, -1, -2, -3, -4? What numbers do I try? I'm just taking a stab in the dark at what numbers to try. I may try 15 or 20 numbers and never get a remainder of 0. So what we need to talk about right now is this. We need to talk about how to make a list of good suspects to try in this list right here. Because there are some numbers that could potentially work. There's some that absolutely could not work. For instance, I'm not going to go into why, but let me just say this. If you tried the number 4 right here, I can tell you right now, 4 doesn't even have a prayer of working. You say, well, how do you know that? I'm about to show you. 5 doesn't have a prayer of working. 1 might would work. -1 might would work. 3 might would work. 2, no way 2's going to work. So what I'm about to do is I'm about to show you how to make a list of numbers. And we call these numbers rational numbers. They're whole numbers and fractions. But this is what I refer to as my suspect list. The book calls it the set of possible rational numbers. The set of possible ones. So I'm about to show you how to generate a group of numbers. It's kind of like, this is a silly example, but it'll make my point. Whenever a crime has been committed, what's the first thing they do? They make a suspect list. You know, for instance, as awful as it would be, if a child's been abducted, what do they typically do first? They start with typically the members of the immediate family. That does not mean that a person in the immediate family abducted that child. It's just where they start. It's their suspect list. And then if they don't find the person, then they move outside of that suspect list. Well, this possible rational numbers is called your suspect list. And here's how you generate these possible rational numbers. Here's the formula. There's the formula for the set of possible rational numbers. You need to memorize that formula. Now, let me, right up under here, write this. Right up under here. Write C represents all of the factors of the constant in the polynomial function. All right, right up under that, write this. L represents all of the factors of the leading coefficient in the polynomial function. So C is for the constant and L is for the leading coefficient. All right, so what this formula is going to do is going to generate a group of numbers. And those are the numbers that we'll start out trying. Okay, so what I want to do first is I want to make up a problem and show you how to make the suspect list. This is when you don't know any zeros at all. This is where you start. Okay, write these instructions down. List the set of possible rational zeros. List the set of possible rational zeros for the polynomial function. List the set of the possible rational zeros for the polynomial function. Okay, so we're going to just do 2 quick examples on this. All right, so let's look at this first example. F of x equals to x to the third minus 7x squared minus 2x plus 6. Now, this problem has 3 zeros, but I don't know any of them. So the first thing I want to do is I want to generate my suspect list. All right, so how do we do that? How do we develop our list of suspects? That's the possible rational zeros. So it's this formula right here. So it's plus or minus C over L. Now, what does the letter C stand for? C stands for the constant. The constant is the number that's, that has no variable with it in your polynomial function. Now, what does C represent? C is not the 6. It's all of the factors of 6. So, what are all of the factors of 6? In other words, what are all of the numbers that divides evenly into 6? It would be 1, 2, 3, and 6. Those are all of the numbers that divides into 6. Now, what does L represent? L represents all of the factors of the leading coefficient. The leading coefficient is the number that's in front of that very first term. All right, that's just a 1. So the only thing that goes into 1 is 1. Now, I don't want you to leave it like this. I want you to separate it out. So here's what it would be. Plus or minus, 1 over 1 is 1. Plus or minus, 2 over 1 is 2. Plus or minus, 3 over 1 is 3. Plus or minus, 6 over 1 is 6. So there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers in this list. So here's what we would do. We're not ready to do this yet, but here's what we would do next. We would start trying these numbers, doing synthetic division on this, till we found one that worked. So I would try 1 and negative 1, 2 and negative 2, 3 and negative 3, and 6 and negative 6, till I found the one that worked. Or found at least one that worked. Now remember, once you find one that works, you can stop, and because you can find the other two by working with your answer. I'll show you that in just a few minutes. So, do you see the number 4 in this list? No. So there is no need in trying synthetic division with 4. It could not possibly work. These are the only possible rational numbers that could work. Now, not all of these aren't going to work, but there'll be one in this list that's going to work for us in here. So you'll find the one that works, and then you can finish the problem. All right, before we go any further, let's do one more, where we just make the list. And again, the instructions will say list the set of possible rational zeros. So let's look at this example right here. F of x equals okay. I want to do my suspect list. Okay, here's the formula, plus or minus C over L, which is plus or minus, okay, C. C is all of the factors of 6. Well, we just did that. All of the numbers that divide into 6 was 1, 2, 3, and 6. Now, L. L is all of the factors of the leading number. What are all of the numbers that divides into 8? 1, 2, 4, and 8. Now, I told you I don't want you to leave it like this. So what I want to do now, this one's a little different to separate out. So let me show you how to do this. Let me show you, to me, the easiest way. Start out and circle this 1. Now, here's what I'm about to do. I'm about to put these 4 numbers all divided by 1. All right, so here we go. 1 over 1 is 1. 2 over 1 is 2. 3 over 1 is 3. 6 over 1 is 6. I like doing that. That way you're listing all of the whole numbers first. Okay. Did I put all 4 of these over 1? Yes, I did. Now, mark out the 1. Now, go to the 2 and circle it. All right, do the same thing again. 1 over 2 is a half, comma. 2 over 2 is 1, but I have it. 3 over 2 is 3 halves. 6 over 2 is 3, I have it. So did I put all 4 of these over 2? Yes, I did. So I'm going to mark that out. Now, circle the 4. Put every one of these over 4. 1 over 4 is a 4. 2 over 4 reduces to 1/2. I have that. 3 over 4 is 3/4. And 3 over 8 is 3/8. Now I'm done. I'm sorry. I said that wrong. Let me do that again. 1 over 4 is 1/4. 2 over 4 is a half. 3 over 4 is 3/4. And then 6 over 4, sorry about that. 6 over 4 is 3 over 2. I have that. Now I can mark that out. Now put all of these over 8. 1 over 8 is 1/8. 2 over 8 reduces to 1/4. I have it. 3 over 8 is 3/8. And 6 over 8 reduces to 3 over 4. I have it. Now keep in mind, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is really 20 numbers. And the reason is, there's all the positives and all the negatives. Now, I'm fine with you leaving it like, don't leave it like this. I'm fine with you leaving it like this. The homework puts plus or minus 1, plus or minus 2, plus or minus 3, plus or minus, it puts the plus or minus in front of every one of them. I don't care that you write it out like that, as long as you got the plus or minus in front of every one of them. So that's 20 numbers. So what would we do next then? We would start out and we would do synthetic division until we get a remainder of 0. Now, let me go ahead and tell you this for the sake of time. You say, well, Mr. Hunter, am I going to have to do every one of these numbers? Not necessarily, and here's what I mean by that. For the sake of time, I'm not going to give you one that's got 30 numbers in it and you got to try all 30. If I do that, you're never going to finish. So here's what I will do. I will make sure that the ones I give you, I'll make sure that one of the whole numbers works. So that way you don't have to try the fraction ones. Now, is it possible that the fractions will work? Yes. But for time's sake, I will make sure that one of these 4 work. So if you try the first 4 whole numbers and you haven't found a remainder of 0, that means you made a mistake somewhere. So, all right, but right now you just need to make the whole list, because I will have that question on test. I'll say make the list of possible rational zeros. Now what we're about to do in the next video is we're going to take this list, start trying some that work, until we find the one that works. So I'll stop the video here and we will pick up with video number 4 next.